Rules of derivatives. Okay. The first rule is that sum and difference rule. That is ddx of fx plus minus gx. ddx of fx plus minus gx is equal to ddx of fx and plus minus ddx of gx. We separate each term and we differentiate each term separately. Okay. The product rule yesterday I told you that that is last lecture I have told you that ddx of fx gx, that is a product will be the first. We will find out the ddx of the first function, then and I keep the second function as it is plus the first function as it is, then ddx of the second function. Okay, ddx of the second function. This is okay. Yesterday we have done the last lecture. We have done the sums on this. Now I teach you one division rule, that is division rule of derivative. If the fx and gx are continuous, then only we can find out the derivative. ddx of fx by gx, where gx not equal to 0, gx not equal to 0, that is, it is not a zero function, then it will be, first we will find out the derivative of the numerator, then I keep the denominator as it is, minus ddx of the denominator, and I keep the numerator as it is, and divided by the numerator, that is this is numerator and this is denominator whole square. So the rule, first rule is sum and difference rule. First rule is sum and difference rule. Second rule is product rule, and third rule is that is the division rule. So instead of two functions, I can take 3, 4, 5 as it is, how much I want. Similarly here, the product rule, that is fx, gx and hx, if suppose there are three functions. So therefore, first function differentiate and other two function leave it as it is. Then similarly, like we will do it by one by one. First function as it is, second function I differentiate, and third as it is. Okay, similar, then the third, first and second, they are as it is, and the third function we differentiate. Okay, fine. Then the division rule, this is, I have already explained you, that is gx is not equal to 0. Why? Can you tell me why gx is not equal to 0? Gx is not equal to 0 because this division is not defined. So I think first function differentiate into the second function minus second function differentiate into the first function divided by second function whole square. Good. Right. First part. Solution of the first part. That is, let y is equal to e raised to the power x upon 1 plus x square. So this is the numerator and this is the denominator. That is the quotient rule. We will apply quotient rule. So therefore, dy dx is equal to ddx of e raised to the power x into 1 plus x square and minus e raised to the power x into d dx of 1 plus x square. Okay, it is okay. Just see. It becomes that is e raised to the power x is what? E raised to the power x I have to divide by 1 plus x squared whole square. That is e raised to the power x. It means e raised to the power x into e raised to the ddx of e raised to the power is e raised to the power x into 1 plus x square minus e raised to the power x and ddx of 1 plus x square. Ddx of 1 is 0. This is constant, and plus x square is 2x into 2x. That is divided by 1 plus x square whole square. That is equal to, I can take e raised to the power x common. So I can take e raised to the power x common. So I have got 1 plus x square minus 2x. Okay. And 1 plus x square whole square. This is 1 plus x whole square. This becomes e raised to the power x 1 plus x whole square 1 minus 1 minus x whole square divided by 1 plus x square whole square. Okay. Now, have you followed? Yes. That I have done with the rule. I have used the rule. Question number 2. Let y is equal to 1 plus e raised to the power x divided by 1 minus e raised to the power x. Therefore, dy dx is equal to dy dx is equal to first that is ddx of dy dx, that is 1 plus e raised to the power x into 1 minus e raised to the power x plus minus 1 plus e raised to the power x into d dx of 1 minus e raised to the power x. Okay. Divided by, what will be there? Divided by 1 minus e raised to the power x whole square. The square of the function. Okay. Then this means ddx is 1, 0, that is 0 plus e raised to the power x into 1 minus e raised to the power x minus 1 plus e raised to the power x into minus e raised to the power x divided by 1 minus e raised to the power x whole square. Then I simplify with this. This will be cancelled. E raised to the power 2x x square, e raised to the power x into e raised to the power x, that is e raised to the power x divided by minus e raised to the power x into e raised to the power x. Okay, minus 1 minus that is 1 minus plus, this minus will become plus, then again minus e raised to the power x and e raised to the power x divided by 1 minus e raised to the power x whole square. Now you simplify, this is minus and this is minus plus, this will be the plus. Okay. So I will cancel it. Then it will be e raised to the power x change the pen. Let me change the pen. Okay. E raised to the power x plus of 1 plus of e raised to the power x plus of 1 plus of 1 divided by e raised to the power x 1 minus e raised to the power x. Similarly, this you can do, that is sin x, 1 plus sin x, that is let y is equal to sin x by 1 plus sin x. So why don't you do it yourself? This is sin x is cos x into 1 plus x minus that is minus sin x into 1, sin x into 1 divided by 1 plus x whole square. This is, I will ask you to do it yourself. ये लो तुम्हारा